All right, y'all. Welcome to what I'm going to call the rational approach to solving equations. This is going to be all about how to solve rational equations. Remember, guys, rational functions, which we've been learning about recently, are just any sort of function which can be written as a fraction of polynomials. So this fraction of polynomials will come up a lot in the future in our math classes. And what we need to be able to do is solve any kind of equations which contain terms with these rational expressions. So we're going to be seeing a lot of these kind of fractions of polynomials adding, subtracting, equal to each other, and we're going to need to be able to solve the equation for the variable. What we're going to do is start off by taking a look at these steps I've outlined of sort of my strategy for how to solve a rational equation, along with an example of one. So let's go ahead and get ourselves on started. All right, so here we have an example of a rational equation. You can see I have 2 over x squared minus 1 over x minus 1 equals 1/2. Notice that this equation has these x terms in the denominator. That's going to be a really important part about this. The key focus of rational equations is going to be these denominators. So let's look at our steps for how to solve this equation. First off, I say always start by factoring all the denominators as much as possible. This includes any integers which can be factored. So we're just going to start off by factoring these denominators. X squared minus 1 is a difference of squares. So I'm going to rewrite that. And that's going to be x minus 1 times x plus 1 because of difference of squares. X minus 1 cannot be factored, so I'm going to leave it as is. And 2 is not going to be able to be factored, so I'm going to leave it as is. Next, it wants me to determine the least common denominator, which contains all possible factors. Now, what this least common denominator means is just looking at all the denominators, right? All the factors on the denominators. What is something that I can come up with that is like the smallest expression that contains everything? So for example, I know I need my least common denominator, my LCD. It's going to need to have x minus 1, right? As a factor, it needs to have x minus 1. And that'll cover here, and that'll cover this guy, right? What other factors do I need? I need x plus 1, right? And what else do I need? Oh, I need this 2, actually. I'm going to need that 2. So notice how this expression here, 2 times x minus 1 times x plus 1, it has it contains all the factors of each denominator, right? I'm not saying that I'm taking each denominator and multiplying them all together, right? That would give me x minus 1 squared here. I don't need to write x minus 1 more than once, because what's going to happen is I'm going to take this least common denominator and multiply it to every term, right? Essentially, I'm multiplying the entire expression by this. It's going to make a lot more sense once we see it done. So let's go ahead and try it. So I'm going to multiply every single term by 2 x minus 1 x plus 1. So I get, here I would get 2 times 2 x plus 1 x minus 1. Oh, you'll notice I already switched them. I'm gonna write it the way that we had it written, just for the sake of clarity. It doesn't really matter, but I feel like it. So I'm multiplying that on the top of this expression. I'm going to do the same thing over here to the minus 1 over x minus 1. So that would leave me with 2x minus 1, x plus 1 on top, all over the x minus 1 on bottom. And on the right hand side, I have 1 times this, so I would get 2x minus 1, x plus 1, all over 2. So see how what I've done is I've essentially multiplied all of the 3 of the terms by my least common denominator. Now that I've done that, right, now that I've multiplied all the terms in the equation by this least common denominator, I'm going to simplify each term by canceling any common factors. Okay, so notice how check this out. This is where it's going to actually, yes, right now it looks really ugly, but it's going to get really nice. Because watch, x minus 1 and x minus 1 will cancel out because these are factors, right? Factors being they all multiply. X plus 1 will cancel out. X minus 1 and x minus 1 will cancel out here. And here the 2's will cancel out. So let's look at what does that leave me with. I'm going to have to zoom out a little bit. So that leaves me with, on this term here, just 2 times 2, which is 4, minus 2 times x plus 1. And that's equal to x minus 1 times x plus 1. Now, when I simplify this, this should eliminate all of the denominators in the equation. Notice how I no longer have any denominators because I multiplied by my least common denominator. If you end up with any denominators, right? If there's, like, let's say that I ended up somehow with like an x plus 1 on the denominator somewhere or something like that, it usually just means that you must have accidentally not had enough factors in your least common denominator. It's a simple enough fix. All you have to do is just multiply, like just continue, right? Just if you still have denominators, just continue multiplying by the denominators, right? So in general, guys, what we just did here was we just took all the denominators of this expression and multiplied everything by those denominators, because that allows us to now have an equation, which is simply a polynomial equation, right? Notice once you've eliminated all the denominators, you just have a polynomial equation, right? So we already know how to solve these. Just got to simplify things, combine like terms, set it all equal to 0, factor it, and solve it. So let's go ahead and do that real quick. X minus 1 times x plus 1 is x squared minus 1. 2x, or minus 2 times x is minus 2x. Minus 2 times 1 is minus 2, but I also had a 4 here, so that's going to be plus 2. And let's see, I'm gonna draw a little line here to sort of separate my work. Going forward over to here, I am gonna move all my terms to one side. I'm gonna actually move all these terms to the right hand side just because I like to keep my x, like whatever my leading term is gonna be, I like it to be positive. That's just kind of personal preference. So I'm gonna do that by adding 2x over, and so I'd have x squared plus 2x. And then this 2, I'm going to have to subtract over. Negative 1 minus 2 is minus 3. Now I just factor and I can solve it. This would be x plus 3 times x minus 1 equals 0. So I get x equals negative 3 and positive 1. And look at that. I've solved the equation. Now, as good math students, what I'm going to do, or what we're going to do, is we're going to look back at our original equation. Because once you solve an equation, it's always valuable to look back at what you started with and just kind of give yourself a reality check. Make sure that your answer makes sense. Okay. Negative 3 plugged into this. Let's think about it. Actually, we could double check our work. Why not? Negative 3 squared would be 9. Minus 1 would be 8. 2 over 8 is 1/4. Okay. Negative 3 minus 1 is negative 4. Here, I'll write that there. I would have 1/4. Negative 3 minus 1 is negative 4. So this is negative 1/4, but I'm subtracting it, so it's plus 1/4. And it equals 1/2. Is that true? Yes, it is. Right? 1/4 plus 1/4 is 1/2. Now, I'm not actually expecting y'all to always plug it in every single time. I know that people get lazy with that. But here's the real thing that we need to check. Look at what happens when I plug in 1. When I plug in 1, 1 squared is 1, minus 1 is 0. That gives me 2 over 0. Already this is a problem, huh? Because remember, guys, we're not allowed to divide by 0. We cannot divide by 0. It's undefined. So how is it that my solution had an undefined answer? Now, that's a bit complicated. It's because it has to do with the fact that we took these denominators and we multiplied by them. And essentially what happens is sometimes you can actually, by multiplying all of your terms, you can end up creating what we call extraneous solutions. Extraneous. So this solution of x equals 1, we're going to actually cross it off because when I look back at my original equation, I know that this is one of the zeros of the denominators. So I know that it is not a possible solution. This is really the only reason why we necessarily need to look back at the original equation, is for these extraneous solutions. Just always keep that in mind, y'all. Let's go ahead and take a look at another example, so that way we can kind of continue to get ourselves some practice. All right, here we are with our second example. So let's go ahead and give this one a shot using the exact same approach, right? So we start off by factoring all the denominators as much as possible. So x plus 2 doesn't need to be factored. 3x minus 6 can be factored. It has a common factor of 3. So I'm actually going to pull that out because, and I really recommend, I do want you guys to include any integers that you can factor out. Okay. So let's see, what does that leave us with? We have 3 over x plus 2 plus x plus 6 over, I'm going to pull out the 3. So 3 times, that leaves you with x minus 2. And that's equal to 2x plus 2. You'll notice that I don't actually factor the numerator. That doesn't matter. I don't need to do that. It's just the denominator that we're factoring. And x squared minus 4 is going to be a difference of squares again. So that's going to be x minus 2 times x plus 2. So let's try to figure out what is our least common denominator, right? We need to determine the least common denominator. Well, I can see I need a factor of x plus 2. I need a factor of 3. And I need a factor of x minus 2. I need a factor of x minus 2, but I already have it, so I am actually good on that one. I need a factor of x plus 2, but I already have it. So this is my least common denominator here. So what I'm going to do is I'm going to multiply this to every single term. Now, you'll notice in this problem and in future problems, I'm going to typically not actually... I'll do it one more time. I'll show the work of multiplying this out, but most people don't actually do that. I kind of am going to recognize which factors will end up getting canceled out, right? I see the x plus 2 is going to cancel. So really, I only need to multiply this term here by 3 times x minus 2. I'll show you guys the steps just so that we see it one more time, though. So 3, x plus 2, x minus 2 is going to multiply everything. That leaves us with 3 times 3. 3 times 3 is 9. I'm going to do that just because. X plus 2, x minus 2, all over x plus 2. Multiplied to this guy, I get 3 times x plus 2 times x minus 2 times the x plus 6, all over 3x minus 2. And it's equal to 2x plus 2 times all of this. So a 3, the x plus 2, and the x minus 2. And it's all over x minus 2 times x plus 2. It is kind of fun to write it out in the long form, though, because you kind of get to see everything cancel out, which is cool. So here we see x plus 2's cancel. Here we see 3's cancel and x minus 2. Here we see x minus 2 cancels x minus 2, and x plus 2 cancels x plus 2. So remember, guys, what we've done here is we factored the denominators, found the least common denominator, right, the thing that contains all of them, multiplied by it, and simplified. And look, what are we left with? We're left with 9 times x minus 2. Plus x plus 2 times x plus 6. And that's equal to 3 times 2x plus 2. And look at that. It is now a polynomial equation. So once I've eliminated all the denominators, I simply have to solve it as a polynomial equation. Let's go ahead and do that. 9 times x plus minus 2 is 9x minus 18. 9x plus x plus 2 times x minus 6, or x plus 6 would be, let's see, x times x is x squared. 6x plus another 2 is 8x. And 2 times 6 is 12. And this is all going to be equal to 6x plus 6. I'm going to go ahead and move these guys over, combine my like terms, and get it equal to 0. So I'm left with, I have 1x squared term. I have 9x plus 8 is 17, minus the 6 is 11x. I have negative 18, plus 12 is negative 6. This 6 is going to subtract over, so negative 6 minus 6 is negative 12. And it equals 0. Let's go ahead and factor that. This will factor to x plus 12 times x minus 1. So what are my solutions then? X equals negative 12 and 1. Are we done? No, there's one more thing we should do, right? We should check our solutions for extraneous solutions. Let me type that, by the way. Extraneous solutions. Just so that you guys have sort of seen what that looks like. So we're looking for extraneous solutions. I don't know if that actually needs 2 n's. Yeah, it looks right with 2 n's. Let's leave 2 n's. We'll say that looks right. So really what we're looking for, guys, is we're just looking at the factors that we got. It should be pretty simple to check extraneous solutions. You're just looking at the factors you have in the denominator and seeing if any of these are the zeros of those factors. Is negative 12 a 0 here? No. Is 1 a 0? No, we don't have any x minus 1. So we're actually good with both of these. So this is our solution. Look at that. Easy money, y'all. You guys want to do one more example? Yeah, you do. Hell yeah, man. Let's do one more example out here. All right. All right, here we are with our third example of a rational equation. Let's get it. Hey, what do you guys know? We're going to start, as we do, by factoring all the denominators. You'll notice that this has a very big pattern, guys. You pretty much just do this. I swear, guys, anytime you're solving equations, even if it's not like, my class, it's just some future math class. If you're trying to solve an equation and there are fractions with x's on the bottom, if there's x's in your denominator, get rid of them. That's always your first step, is to get rid of the x's from the denominator, because x's in the denominator are always just a real pain in the ass to deal with. So we just get rid of them as best as we can. And the best way to do so is to find the least common denominator, like we've been doing. How do you find the least common denominator? It's by factoring it, because then you can see the factors. It helps us out a lot. So I digress. Let's factor these denominators. Oh, this one's gonna be a little bit more fun to do. Okay, so cool. So we got here. I'm gonna show you guys how I would show my work usually. Usually what I would do is this. I would just look at this thing and I'd be like, okay, what are my factors? It's gonna be 2, right? They both have a factor of 2. Oh, and x actually. And that would leave me with x minus 4. So I'm just kind of identifying what it breaks up into, because I'm just hoping to find my least common denominator, right? What about 4x squared minus 2x? This could factor out a 2x as well, and I'd be left with 2x minus 1, right? And then this guy here, 2x squared minus 9x plus 4, is a fun little quadratic. It's going to be, let's see, 2x and x. I'm just doing that double cheek method that I always talk about. And I need factors of 4 such that this will make negative 9. Minus 4 and minus 1, because 2 times 4 is 8, and 1 with 8 makes 9. Hell yeah. All right, guys, so now let's make our least common denominator. Okay, I want a factor of 2x, right? and I want a factor of x minus 4. I want a factor of 2x, but I already have it. And I want a factor of 2x minus 1. I want a factor of 2x minus 1, which I already have, and a factor of x minus 4, which I already have. Excellent. So this is my least common denominator. So what we're going to do now is multiply this to all of the terms. All of them. But you know what's hella nice, guys? You don't actually need to show all that work, right? You don't really need to show that. Or do you? Yeah. I want to show you guys. Look. If I'm multiplying this to this term here, look at dude. The denominator has 2x and x minus 4. So I know right away that those will cancel out. What would that leave me with on top? It'll leave me with 2x minus 1, right? So really, this term should all simplify into 2x, which is the original numerator, times the 2x minus 1, which would be left over. Simply because the other two factors of 2x and x minus 4, right? These two factors are going to get canceled by the 2x and x minus 4 on the denominator. You see how those canceled? Cool. What about this term? Well, notice how they both have 2x, so those will cancel. They both have 2x minus 1, so those would cancel. So I'd be left with just 3 times x minus 4. And it equals 2x minus 1 cancels. X minus 4 cancels, so I'm left with 2x multiplying the top. 2x times x minus 3. I'm going to go ahead and erase these guys that I canceled. Let's move that. Let's move those guys next to each other. All right. So cool. And look, it's a polynomial. It's a polynomial equation. Let's solve it. Solve it easy money, guys. 2x times 2x is 4x squared. 2x times minus 1 is minus 2x. 3 times x is 3x. 3 times minus 4 is minus 12. And it's all equal to 2x times x is 2x squared. 2x times minus 3 is minus 6x. And we need to move all the terms to the left-hand side and combine like terms and all that. So what do we get? 4x squared minus 2x squared leaves me with 2x squared. Minus 2 plus 3 is 1x. I'm going to have to add 6 more over, so I'm left with 7x. And I'll just be left with this minus 12 here. We could factor this guy. Hell yeah, we can. 2x and x. Factors of 12, please. Factors of 12. Oh, but it's minus 12, so one needs to be plus and one needs to be minus. Okay, I think I see. If I do... You know what? Let's use the diamond. I'm real. I'm doing this on the fly. I don't remember what that factors into. I probably could be knowing it, but let's just do this anyways. So a times c on top, b on bottom. What are two numbers that are going to multiply to negative 24 and add to 7? Oh, it's going to be 3 and wait. Well, shit, guys. Did I just get a quadratic that doesn't factor? Or am I blind? Do you guys know what you do in this case? You scrap it all, or at least this factoring crap that I'm trying to do. And you pull out the big guns. Y'all know the big guns? It's quadratic equation. The big guns is quadratic equation. That's remember guys, x. Oh dude, there's a fun little song for it. Hey wait, we got to turn off this music, this background music for the song. You guys know how it goes. X equals negative b plus or minus square root b squared minus 4ac all over 2a. If anyone knows that one, shout out to Miss Turner. I think She's teaches that still. I love that. So this is the quadratic equation. Remember that, guys? TBT, very useful tool. Let's use it. So x will equal minus b, b being 7, so negative 7, plus or minus the square root of b squared. 7 squared is 48, 9. Minus 4 times ac. 4 times a is 8. 8 times 12 is 96. It's a minus, but then the 12 is negative, so it's going to be plus 96, actually. And it's all over 2 times a, which is 4. All right, well, let's see. So that's negative 7 plus or minus the square root of 49 plus 96 is going to be, I think that's 145. Yeah, that's 145. Oh, no wonder I wasn't able to factor it. This isn't even going to be a whole number or a rational. So the square root of 145 is not a perfect square, huh? Let's just double check. Did I do that correct? 4ac. 8 times 12 is 96, yeah. All right, so this isn't a perfect square. So this is actually going to be our solution. Negative 7 plus or minus the square root of 145 over 4. Now, technically I could try to write this as a decimal, right? I could write this as a decimal by plugging it in a calculator, but I'm a real guys. I actually hate decimals when they come from a square root, at least. I hate decimals from square roots because like square root of 145, I kind of can recognize what that means, you know? I can see what square root 145 comes from. I can see the numbers. But like the square root of 145 is like 12 point dot 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 dot. Like when I see 12 point dot 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 dot, like I don't know what that means. Like what is this dot 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 coming from? Like what caused it? So I'm going to actually use this as my solution. And I think that's perfectly reasonable. Any math teacher who tells you that that's not okay to be your final solution, if they're grading you, listen to them. But I think that they're wrong. All right, guys. So that's our solution for example 3 here. A very fun one. That one, you know what? That one didn't feel quite right. That felt like we can't end on that, huh? All right, this one's for the real dedicated folk out here, guys. We got to do one more example. All right, let's get it. All right, I promise this is the last example we'll do. And I think this is one that I actually made kind of special for y'all. Because I think it's got some fun little topics to discuss. So we're going to start off doing what we always do. Factor the denominators. Luckily for us, there's only one denominator to factor, actually. It's this one. 2x squared minus x. That's going to factor into 2x times x minus 1. That's not true. It's going to factor into x times 2x minus 1, right? I can't pull out a 2. But I can pull out an x, and I can leave in 2x minus 1. So here's an interesting thing. When there's only one, like, notice how this guy's got the x, this dude's got the x, right? Yes, it's a negative x, but my least common denominator can pretty much just be this x times 2x minus 1, right? Because these terms here don't even have denominators. Pretty nice for us. So my least common denominator is going to be that. So I'm going to multiply this to every term. When I multiply 15x over literally this least common denominator, and I multiply it by the least common, it's going to cancel out, right? So I'm going to be left with 15x from this term. I'm going to multiply it over here, and the x's will cancel. So I'd be left with minus. Here's a big thing, guys. Don't forget that that minus exists. Don't forget that that minus exists. If I'm subtracting a whole fraction, then this subtraction should be distributing. Remember, this is effectively the same thing as if I had plus and then a negative multiplying it, right? It's the same thing. So I'm going to have 15x minus 3x plus 4 times, okay, let's see. I got ourselves sidetracked. So we're going to multiply by the least common denominator, x, and 2x minus 1. And it's all over negative x, right? What can cancel out here? The x's will cancel. And actually, this negative and that negative will cancel each other out, right? They'll cancel out each other's effect to make it a plus. Oh, so that's nice. It turned out to be plus anyways. This least common denominator will then multiply these guys here. I could do it all at once, actually, if I really want to, but I don't really want to. So I'm going to have minus 2x times x times 2x minus 1. And 4 plus 4 times x times 2x minus 1. And it all equals 0. All right, this looks like quite the mess. We should probably simplify our work a little bit out here, huh? So 3x plus 4 times 2x minus 1. What will that make? 6x squared. 3x times negative 1 is minus 3. 2 times 4 is 8. 8 minus 3 is 5x. And then 4 times minus 1 is minus 4. Okay. This guy here is going to be kind of ugly, huh? We'll be left with, let's combine these guys. That's minus 2x squared, huh? Negative 2x squared times 2x is minus 4x cubed. Minus 2x squared times minus 1 is plus 2x squared. Here we have, I'm going to combine those guys to 4x. 4x times 2x is 8x squared. And 4x times minus 1 is minus 4x. That should bring down my 15x, huh? Whew. This is a long equation, isn't it? This one's kind of mean. This one's kind of evil. Who gave us this equation? That was me? Oh, whoops. All right, let's keep going, y'all. I've gotten rid of all the denominators. So now we just need to combine like terms, right? And then factor and such. So where's my x cubes? I only got one. Nice. Minus 4x cubed. Where's my x squareds? I got 6. I've got another 2. That makes 8. I've got another 8. That makes 16. So plus 16 x squared. Where are my x's at? 15 plus 5 is 20. Minus 4 is 16. Oh, cool. 16 again. And where are my numbers at? I got minus 4. And that's it. So minus 4 equals 0. You guys want to see something interesting? I really encourage y'all to be on the lookout for such things like this. Look at this. Every single one of these terms is a multiple of 4, right? 4 and 16. These are all multiples of 4. And it's actually equal to 0. So I could just divide everything by 4. In fact, I'm going to divide by negative 4 just because I like to keep my leading term positive. That's just my personal preference. So I'm going to divide everything by negative 4. So what does that leave me with? That leaves me with x cubed minus 4x squared minus 4x plus 1 equals 0 divided negative 4 is still 0. Yay! Oh, what do you guys know? Look at this. Is this the cubic? Does that mean that I need to use rational zeros theorem? Hell yeah, it does. But luckily for us, this one's a pretty easy rational zeros because the constant is 1, the lead term is 1, so really our only options are 1 and negative 1. So let's see. What happens if I plug in 1 here? I have a feeling that's not going to work very well. I'm going to create a table. Y'all remember rational zeros theorem, yeah? Don't forget it. Actually, that's not true. I don't expect y'all to actually have it memorized, but I do expect y'all to like keep notes. So so when x is 1, I get 1 minus 4 and 1. That does not equal 0. What about when x is -1? -1 cubed is -1. -1 squared is 1 times -4 is -4. -1 times -4 is +5. Not +5, +4. And +1 is 1. These guys will actually make 0. All right, so we're going to divide. So x equals -1 is my 0. So I know for sure that x equals -1 is a 0. If x equals -1 is the 0, then the factor is x plus 1, right, guys? Remember, think about it, y'all. If x plus 1 equals 0, x is -1, right? -1 plus 1 is 0. So what I'm going to do is I'm going to divide this guy. I'm going to divide it by the x plus 1, or I'm going to factor it out. So I'll have x plus 1 times something equals 0. What is this something? We got to do polynomial long division to find that. We got x cubed minus 4x squared minus 4x plus 1, and dividing out x plus 1. That's going to be x squared. Remember to subtract it. -4 minus 1 is minus 5x squared. So I need to have a minus 5x, because minus 5x times x is minus 5x squared. Minus 5x times 1 is minus 5x. Subtract those. -4 plus 5, right? See how minus minus? So -4 plus 5x is 1x. Oh, and look, I'm left with 1. X squared minus 5x plus 1. So that leaves us with solutions. X equals -1. And whatever the answer to this thing is. I'm real, guys. We're gonna have to use quadratic equation for that one. I'm gonna do it real fast. I feel like this video is long enough as is. Negative b plus or minus the square root of b squared minus 4ac, so minus 4 all over 2. That's gonna be 21, the square root of 21. So 5 plus or minus root 21 over 2. There's our solutions to this equation. Whew, that was quite the problem, huh? Whoever made up that problem, kind of evil. Well, y'all, that's a lot of examples about how to solve equations which have rational expressions. Now, if you guys have any questions or concerns, or you got lost by one of these solutions, please feel free to message in the math discussion channel on our Discord. Go ahead and, post a timestamp. Just tell us, hey, Mr. Hoba, I was confused about this part at time 10 minutes and 34 seconds. Could you elaborate? And I'm totally down to talk more about these things, but I feel like this video has had enough explanation for 1 week. So with that in mind, y'all, hope y'all have a good day, and I'll see y'all next time.